Okay, before we move on to multiple events, we're going to review single event, and we're going to add a couple extra examples with single events. So just in quick review, with the coin toss, there's two possible outcomes that can happen, either a heads or a tail. That's a 1 out of 2 ratio, and to figure out your probability, you know it's common sense. The math is there to prove it. You have your event, which is either your head or your tail, which is signified by one number, 1. And there's only two possible outcomes that can happen, either heads or tails, so that's 2 that goes in the bottom of your formula. Your formula is event over number of outcome, gives you your probability. And if we were to work the formula out, and we put our 1 in and our 2, do our division, we'd get 0.50, which translates into a 50% chance of it being either a heads or a tails. The roll of the die, same idea there. You have 6 numbers, or your number of outcomes is 6. You have 6 numbers, so the chances of any one number is once, because it can only land on one number. So your number becomes 1 over 6. And here's what it looks like, 1 over 6. You follow your formula, divide your event over the number of outcomes, gives you your probabilities. Event, outcomes, division gives you 0.16 or 0.16 or 16% of a chance that the number will land either on a 1, 2, 3, 4, 5, or 6. So if you're a gambling person and you put $50 on number 3, you've got a 16% chance of being able to collect your monies. So just remember, event divided by number of outcome gives you probability on single events. Here's a variation of the die example. This time here we're looking at the probabilities of what are the chances that when you roll your dice that it's either going to be an odd number or an even number. Okay, that creates 2 sets. Your first set is your set of odd numbers, 1, 3, and 5. Your second set is your even numbers, 2, 4, and 6. But still, that die can land on any one of those 6 numbers. So your number of outcomes remains the same, 6. But now you're working with 3 numbers. Those 3 numbers become your events. And when you do the math, you do your division to find out your probabilities. Event over number of outcomes gives you 0.50, or that you have a 50% chance that you're either going to land on an odd number or an even number. Very much like the coin toss in that sense. So that gives you a 1 out of 2 ratio. Remember the formula. Event over number of outcome gives you probabilities. This next one is a little different. It's just again, it's a variation. Rather than a coin, a dice, this is just a number of marbles. So in this examples, we have a total of 23 marbles. That gives us our possible number of outcomes, because if you're going to choose, you're going to choose 1 out of those 23. You can't go 1 out of 24 because there isn't 24 marbles. You can't go 1 out of 22 because there's 23 marbles in this little container. So for this example, we assigned 1 black one, 3 yellows, 5 greens, 6 reds, and 8 blues. So the question is that what are your odds are on one pick that you're going to pick a black? What are your odds are that you're going to pick a yellow? What's your odds are that you're going to pick a green? What is your odds are that you're going to pick a red? Or what's your odds are that you're going to pick a blue? Well, these numbers, they tell you the frequency of the colors. Well, these numbers become your event. Of course, your total numbers of marbles is your total outcome. So that number would go here, 23. And if you're using black, your event would be 1. If you're using yellow, 3, 5 for green, 6 for red, and 8 for blue. Once again, you use that same formula, and I keep repeating that same formula because it's through repetition that it gets into memory. Event over the number of outcome gives you probabilities. Okay, enough of the theory. Now we're going to go to the spreadsheet, and I've already written out the formulas. This number here is based on this formula here. Now, this is what that one is, so I couldn't put zeros in because the spreadsheet doesn't like it. It gives me a division error. So we'll do our coin toss first. For quick review, you have, it's either going to be a heads or a tail, so that's only one of those events can happen. But you do have 2 possible outcomes. So I'm going to change my outcome to 2 possible outcomes. Hit my enter. And that tells you you have a 50-50 chance. You have a 50% chance of being heads or a 50% chance of being tails. With our die example, for any one numbers, we have the die can only land once on the number, so it could be a 2, 3, 4, 5, or 6, but it can only land when you do your toss. It can only land on one of those numbers, but there's 6 possible outcomes. Number, event over number equals probability. So we're going to change, since we know our event, we're going to change our number of outcomes to 6. Enter. And that gives us a 17% chance. Actually, it's 16.5 because it's greater than 5. It rounds up 17%. Okay, so we're still staying on the die, but this time here working with the odds and evens. There are 3 numbers in the odds, and there are 3 numbers that are even. Gives us a total of 6. That's our number of outcomes. So we change our events to 3. We hit our enter, and we let the old machine do its calculation, and we see that there's a 50-50 chance that it'll either be an odd or an even number. Pretty straightforward. Remember the formula, event over number of outcomes gives you probability. So let's look at a practical example, a fundraiser. So okay, we're going to look at an application of probability. You're the chairperson of an organization, and you want to generate a little money through a fundraiser. So what it is, you get a little jar and you load it up with marbles, and you put 1 black marble into it, 3 yellows, 5 greens, 6 reds, 8 blues. That gives you a total of 23 marbles. And to make it enticing, if the person picks a black marble, they'll get $50. If they pick a yellow, they'll get $1. If they pick a green, they'll get 50 cents. A red, 40 cents. Blue, 25 cents. The rules of the game is that 1 ticket for 1 play and only 23 people. Again, there's variations to that, but to get the basic concept, that's all what's needed. So it's just within those rules. So for each player, they've got a 4% chance when they pay their $30. They've got a 4% chance of making $50. So they'll come ahead by $20. They've got a 13% chance of getting $3. They've got a 22% chance of getting $2.50, 26% chance of getting $2.40, and 35% chance of getting $2. And we see that our totals work out 100%, and the total probable payout is $59.90. Okay, you sold 23 tickets at $30, so you've got yourself $690 in your kitty. And the number of people tickets sold shouldn't be $1 it should be just 23. And so your total sales $690. Total possible payouts is $59.90. So your profits, your probable profits are going to be $630.10. And whether, the actual game comes out, but what the actual game does tell you is that you're going to make a profit. So how did we come across all these figures? Okay, well, we know what our total number of outcome is. There's 23 down here. And each number, the 1, 3, 5, 6, and 8, that is our event. So in the first instance, which is already worked out, we have event over outcome gives us probability. So for 1 out of 23, we get 4% chance. So that's what the person has for a chance of getting that $50. Okay, so we go down to our next and we change the number to our 3 using the formula. Event over numbers of outcome gives us probability. So with a 3, 13% chance that they're going to get $3 on that one play. So we move down our numbers again. We add 5, and we now see that the one player has a 22% chance of getting $2.50 on their $30 play. Okay, we move down, we go to and add a 6, and so to get $2.40, 26% chance. We go now to the 8, to the blue balls. What are the odds of getting blue balls? That doesn't sound right. What are the odds of getting blue balls? Sounds kind of sexual, doesn't it? Anyway, they have a 35% chance of getting their $2. And of course, because you're trying to make money, you set up your payouts in that way. The greater the chances are, the less of a payout, the less of a chance to win. You increase the payout. So the greater the probability, the lower the payout. The lower the probability, the higher the payout. And you've seen that the formula, event over number of outcomes equals probability, once again holds through, and it's a useful tool for trying to calculate probabilities on single events. The next tutorial will be on multiple events. That'll be 2 coin toss, 2 die toss, or 3 coin toss, 3 die toss. There's a formula to calculate what your probabilities are. And once again, while this seems to be very simple, which it is, and the next is very simple, and each one is very simple. But before you can go to the next stage, you have to have the first stage down pat. Eventually, you'll get into having to work out standard deviations and variance. And if you don't understand this earlier stuff, standard deviation, variance, may be a little difficult to grasp. Now, I'm sure they're not going to take you to the levels having to work what's called an NOVA table. That's an entire stats course to get there, and working out your chi-squares and that. I don't think you're going to be required to do that in the course. So anyway, hopefully this all makes sense, and